Consider these two straight lines that cross at a particular point. We also have a 40-degree angle marked where the lines cross. Using this angle, this single angle that is marked, it should be possible to find, this angle here marked in orange. How could we do that? Well, we could use the fact that this here is a straight line, and the 40 degrees and the orange angle together sit at a particular point on that sloping straight line. That means that those two angles add to 180 degrees because angles at a point on a straight line add to 180 degrees, which means that the orange angle there should be 180 less the 40 degrees to leave us with 140 degrees. So far, so good. There are two more angles in this setup that we could try and work out the size of. Well, let's try and work out this one here, this green one. Well, surely this time we could look at this straight line here, the one that slopes down in this direction. And we could look at the orange angle and the green angle. And the orange angle and the green angle sit on a straight line at a particular point. And angles at a point on a straight line add to 180 degrees. So the orange angle and the green angle will add to 180 degrees. We've got 140 degrees worth taken care of already with the orange. So the green will be 180 less the 140 to give us 40 degrees. And finally, we should be able to fill in the other angle down here. We've got two options for this now. We could either notice that once again, we have got two angles that sit at a point on a straight line. We could look at this sloping line here and look at the green 40 degrees and the purple angle that we're trying to find the size of. And notice that those two angles will once again add up to 180 degrees. Or we could take into account the fact that we've got four angles around a central point. Angles at a point add to 360 degrees. We could add up the three angles we've already got, take them away from 360, and we will be left with the size of the purple angle. Either way, we're going to end up with the same answer of 140 degrees. And hopefully, looking at those four angles now filled in, we can notice something. We will notice that these two angles here are the same size and these two angles here are the same size. Now this kind of pattern would be true whatever the numbers were. If I changed this from a 40 to say a 50-degree angle, then we would still have the same kind of setup, different numbers, but we'd still have these two angles being the same and these two angles being the same. And this is then an interesting thing. So we can draw another angle rule out of this. And we say that these are a particular example of opposite angles, where the rule in full is that opposite angles are equal or opposite angles are the same. But if we're using this as a property, we can just quote the rule opposite angles.
So whenever we have two straight lines that cross in this way, two of the angles, say for example the angles labelled A, will be the same size, and the other two angles, say the angles labelled B, will also be the same size. We're calling them opposite angles in the sense that opposite angles are equal in size, and we can look for this kind of X sort of shape. Whenever we see any lines crossing in this kind of X shape, we have this opposite angles situation, and we can use that to help us fill in the values of missing angles. Consider these two lines. Now, one of the things we might want to notice about the lines is that they are parallel. So we could add those parallel arrows to these lines to show that they are parallel. Now, if they are parallel, that means that they are never going to get any closer or any further away from each other. I'm going to draw one more thing on this diagram, and I'm going to draw a diagonal line between those two parallel lines. Now, I've chosen to go top right to bottom left. I could equally have done it sloping down the other way, and the same thing that we're going to look at now will still hold true. But I just happen to have gone top right to bottom left. The key thing is, though, that it is a diagonal that cuts through two parallel lines. Now, I'm going to pick out one of the angles on here. There are lots of angles we could look at, but I'm going to pick out this one here in blue. And I'm also going to pick out this one here in red. Now, looking at those two angles, you might be starting to wonder, they look quite similar. Maybe they are in fact the same size. Well, let's test that. Let's see what happens if we pick up this bottom line, the lower of the two parallel lines. What we're going to do is we're going to pick it up and we're going to move it a little bit further up the diagonal. We're going to slide it up the diagonal. And we could do it again. It's almost on top of the blue one. And then actually we could go that one step further and we could put it on top of the blue one. And then let's just fade out the red angle and see what happens. If we fade out the red angle, find that it is indeed exactly the same size as the blue angle. Now that seems like an interesting thing. And bear in mind that I just happened to pick those two angles. The key thing about the blue angle and the red angle there, in terms of matching them up, is that they are in the same position on the top and bottom lines. They are kind of equivalently positioned, if you like. I could pick any other pair of matching angles, top and bottom line, and this same fact would still hold true. So we can draw another angle rule out of this idea. So we could always color code and letter code these corresponding angles to see which ones match up. Well, the idea is that angles that are in the same position on one of the parallel lines and the other parallel line are the same size. So we have the two angles labeled A will be the same size, the two angles labeled B will be the same size, the two angles labeled C will be the same size, and the two angles labeled D will be the same size. And we can use this corresponding angles idea to fill in missing angles. If we know one of the B's, for example, we can immediately fill in the other B. And we can say that we know they are the same size because the angles are corresponding. And in terms of looking out for these corresponding angles, well, we're first of all looking for parallel lines. If we've got parallel lines, there's a good chance we've got corresponding angles in there somewhere. In particular, though, if there is a line cutting through them, we should be able to see this kind of F-like shape. It might be reversed, it could even be upside down, but we would be looking for this F-like shape to help us find the corresponding angles.
Now there's actually one more angle rule that we can come up with, and it's actually just a combination of the opposite and corresponding setups that we've just seen. Let's consider this case where we've got our corresponding angles marked. Our two A's, our two B's, our two C's and our two D's are equal to each other. What I'm going to do though is I'm going to cover up the bottom parallel line, and we're just going to have a look at the setup on the top. Now on the top I might notice that I have got this X shape where two lines are crossing. Now that means something about the angles that are marked here. That means that the size of angle A and the size of angle C are the same. And that means that the size of angle B and the size of angle D are the same. Why? Because we've got two sets of opposite angles. A and C are opposite each other and are therefore the same. B and D are opposite each other and are therefore also the same. So I could change some of the letters. And instead of C, we're going to write A, and instead of D, we're going to write B, because we've just shown that they are the same, because we've got opposite angles. But surely, I could just repeat exactly this on the bottom line. Because haven't we just got the same setup again with the X shape of two straight lines that cross at a particular point, and surely A and C are once again opposite each other and are therefore the same. B and D are once again opposite each other and are therefore the same. So I could replace some of the letters here. Again, replace C with A and replace D with B, because they are the same size as each other. And then we could look at both lines once more. So what we've done is we have taken this idea of corresponding angles and combined it with the idea of opposite angles to get something new. Now there's quite a lot going on here, so I'm going to get rid of a couple of these letters and just leave us with a few of them. So I've got rid of the angles on the outside of this setup, and I've just kept the angles between the parallel lines. Now let's look on the top. Underneath the top parallel line we've got a B on the left and an A on the right, and on the bottom we've got the A on the left and the B on the right, the same two angles but switched round. What they've done is we've moved from one line down the diagonal to the other, or from one line up the diagonal to the other. The angles have switched round. These two angles, the two B's, are the same size, and these two angles, the two A's, are the same size, which means if we know this angle, if we're given this angle, we can immediately fill in this one. Or the other way around, if we're given this angle, we can immediately fill in this one. And that is then an angle rule, an angle property that we can use. And we say that these pairs of angles, the pairs of angles that are the same, we say that they are alternate angles. Because they alternate, they switch over from one side of the diagonal to the other.
And again, with these alternate angles, there is a handy shape that we can look out for. We can look out for this kind of Z shape. It could be reversed, it could be quite stretched out, but we can look out for this kind of Z shape. And then the angles B and B that nestle inside the Z will be the same. And the angles A and A on the outside of the Z will also be the same. And if we're using this as a property to help us fill in some missing angles, we say that they are alternate angles. And we can just quote that as a fact.
Whenever we look at any of these angles questions, and we're going to do that in more detail shortly, whenever we look at any of these angles questions, it's usually a good idea to start with the diagram rather than start with the particular question. Because if we look at the diagram, we start to spot things that might be useful to us. And one of the things that we might spot in this question is we have two parallel lines. We know that two of the lines are parallel, the one between D and E and the one between F and G, because we've got the parallel line arrows marked on them. We also have three angles, a 62 degrees, a 64 degrees, and a Y. Presumably Y is the angle we are going to find. If we look at the text underneath, DE is parallel to FG. Well, this is why we look at the diagrams first, because we've already noticed that. The words then just confirm what we've already seen. And part one of this question says find the size of the angle marked Y, which again is what we were expecting. Now we are looking at parallel lines, so presumably corresponding angles or maybe alternate angles are going to come into play here. We might, and this is probably the hardest spot, because of those, the X shape, the F shape and the Z shape for alternate is probably the hardest to spot. But we might spot that we do indeed have a Z shape there, which means the 64 degrees and Y must be equal to each other, and so Y will be 64 degrees. Part 2, give a reason for your answer. Why are they the same? Well, we've spotted that Z shape and they are both nestled inside the Z, which means that they are alternate angles. With these questions though, because they are all around parallel lines and the alternate rule just came from the corresponding rule really, there's often more than one way of doing these questions. Because we could also, and we only have to do one, we do whichever one we spot, but as an alternative we could spot this F shape here in orange. The 64, well, there will be a corresponding angle to that above the F shape. That's this angle here will also be 64 degrees. How is that helpful to us? Well, now if we look really closely up at the top, we can see that the 64 and Y meet at that X kind of shape, which means that they must be opposite to each other. So Y, once again, is 64 degrees. If we went with this one, we'd have to do this in a multi-step thing. We'd have to say, well, step 1, we know that this angle up here that we can mark is 64 degrees because it's a corresponding angle. Step 2, Y is also 64 degrees because it's an opposite angle. And either of those options is fine, the one that we've written down or the one that we've just talked through, as long as we give full reasons for whatever we've done. So another example, once again we can see that we have got a nice diagram. And again, before we look at the words, we're going to have a look at the diagram and see what we can see. Once again, we've got two parallel lines and a diagonal running between them. AB and CD are parallel. We know from the diagram that they are parallel because we've got these arrows on them to tell us that the lines are parallel. We've also got two angles marked. One of them we are given 113 degrees and the other one, X, we are not. We might also want to go one step further and notice that X seems to be, from the diagram, an acute angle. That means we are expecting, overall, an answer less than 90 degrees. And if we don't get that, we know that we've gone wrong somewhere. It's usually worth noticing that kind of thing. Let's have a look at the words in the question now. AQB, CRD and PQRS are straight lines. And if we have a look at those, A to Q to B, C to R to D are the two parallel lines. PQRS, P to Q to R to S is the diagonal there. AB is parallel to CD, well A to B, and C to D, we've already said, were the parallel lines. Angle BQR is 113 degrees. We've got an angle marked at 113 degrees, BQR. Let's just remind ourselves of that angle notation. That's B to Q to R, go from the first to the second to the third, and it's the angle at the middle one, at Q. The angle at Q when we go from B to Q to R, which is indeed the 113 that's marked. And then we're asked for part A to work out the value of X. Well, let's do that. A couple of different things we could do, but we are probably going to want to take advantage of the parallel lines in there somewhere and see what we can see. Again, there are multiple different ways we could do this, but I'm going to notice, because it's often a fairly easy spot, the F there. Why am I going to notice that? Well, 113 degrees and this angle here are corresponding. So I'm going to label this with a 1. I'm going to say that that's 113 degrees, and I'm going to write down here that number 1 is 113 degrees, and I'm going to write my reason next to it. Corresponding angles. Part B of this question is actually give reasons for your answer. I'm going to choose to write them next to it so that we can track through exactly what's going on. But that wasn't the angle that I was interested in. I'm interested in X, but I now have enough information to work out the value of X. Because if I cover up the top half of this diagram and just leave myself with the X and the 113, I'm hopefully going to notice that those two sit at a point on a straight line. The straight lines C through to D. And if they sit at a point on a straight line, then they add up to 180 degrees, which gives me the way of working out X. So my step 2, which I'm going to label here on the diagram, X is equal to 180 degrees minus the 113 will leave me with X being 67 degrees. I need to give a reason for that. Angles at a point on a straight line add to 180 degrees. And X is 67 degrees, which is less than 90 degrees like we were expecting. Again, there are more than one way of getting to that X. There are different things we could spot, but this is one of them.